Audio Jungle. Audio Jungle.
Hello friends, here we'll see some examples on Nyquist stability criteria. Nyquist stability criteria mainly gives the closed loop system stability from the open loop trans function, and it is mainly working based on the concept of encirclement. But how we are getting that encirclements? We are going encirclement for the critical point -1 plus z0, that is completely based on characteristic equation. Suppose if I am taking characteristic equation 1 plus g of s h of s is equal to 0, if I write with respect to open loop trans function g of s h of s is equal to -1 plus z0, we get. Means for the open loop trans function critical point is -1 plus z0. Means we are mapping the all the points in S plane towards open loop trans function. Suppose if I am considering this plane is P of S plane, okay, and S plane, if you treat S plane, we are dividing that into real as well as imaginary part, that is two-dimensional plane. We get positive real axis, negative real axis, positive imaginary, negative imaginary. So we are mapping all the points in S plane towards P of S plane with respect to this critical point -1 plus z0. After mapping this, we are going with principle of argument, right? Means we check the number of encirclements for the critical point -1 plus z0, and again we check the is there any number of open loop poles located in right half of S plane. Whenever number of encirclements for the critical point -1 plus z0 is equal to the number of open loop poles located in right half of S plane, then number of zeros located in right half of S plane becomes 0. So system becomes absolutely stable. This is the stability criteria based on the encirclement concept. But when you map the all the points in S plane to P of S plane, what are the different paths we get? Okay, so if you want to map, we should follow with some Nyquist paths. Okay, if I want to cover entire right half of S plane, look into here. If I am starting from here, this is along with the imaginary axis, that is positive imaginary axis, omega is changing from 0 to infinity. Means this one I am considering it as S1 path. When omega is changing from 0 to infinity in frequency domain, nothing but you are drawing again a polar plot. For S1 path, we need to draw the polar plot. Okay, again after reaching this point, our intention is mainly to cover the entire right half of S plane. When I am covering the entire right half of S plane, okay, if you look into this red color portion, it seems to be like a semicircle with radius. Means how much radius? Infinity radius will be there. And what will be the phase angle? If I am starting this phase angle with 0, this is plus 90, this is 180, and this is minus 90. So phase angle is changing from plus 90 to minus 90. So I am replacing for S2 path with S is equal to R e power z theta, but radius we are saying that is to cover entire right half of S plane, so we get infinity. And what will be the variation of phase angle? Theta is from plus 90 to minus 90 degrees. So by that you can cover the entire right half of S plane. This I am saying with S2 path. Okay, after reaching this portion, okay, again we need to come to this point, because our intention is to cover entire right half of S plane when you are mapping from S plane to with respect to this critical point. So when I am following here, if you look into this path, okay, this one I am giving notation like S3. S3 is just a mirror image of S1 only, or inverse polar plot. So S3 is to what? Just cover that mirror image. So mirror image of S1 or inverse polar plot. So when S4 comes, that we will see based on the example, but for this trans function no need to construct S4, because S4 exists only when a pole are 0 located what? Origin only. Now we just given some brief introduction about how to construct the Nyquist path. Now we'll see how to draw that. After that we apply the word principle of argument, and then we identify the word system stability. Generally how we draw the polar plot? Polar plot is nothing but what? Absolute values of magnitude and phase angle with a variation of frequency from 0 to infinity. But if it is in standard trans function, okay, standard mode, then directly we can easily draw the what? Polar plot with some logic. If I am just mapping, look at here, I am just following with this construction of S1. Okay, if you look into this S1, it is what? Type 0, because there is no pole is located origin, so it is a type 0. And what is the order? Order is what? 2 poles means definitely second order. So type 0, order 2. So how to draw the polar plot based on the type and 0? Type indicate what? Starting point of the polar plot. Order indicate what? Ending point of the polar plot. So type 0 means start along with this axis. Type 1 means start along with this axis. Type 2 means start along with this axis. This is type 3. Order indicate what? Ending point or terminating point. So this is for order 1, this is for order 2, this is for order 3, and this is for order 4. But here it is type 0, order 2, so directly we can draw. Okay, type 0 means start from here, order 2 means ends in this position. This one is our polar plot for the given trans function or S1 path in this Nyquist path. Okay, when it comes to the S2, S2 means wherever S is there, replace with R e power z theta. So R tends to infinity only. Infinity plus 2 means infinity. Infinity plus 4 means infinity. Something by infinity means definitely that becomes what? 0 only. That comes at this what? Origin only. So S2 when you cover, it comes at only origin. Because something by infinity means when you are covering entire right half S plane, we are getting mapping at this what? Origin only. What about S3? S3 is to just cover the what? Or draw the mirror image or inverse polar plot for the S1. So when I am drawing that, we will get this kind of path. This is for S3. So we completed, we mapped entire right hand side or even S plane points towards what? P of S plane. But what is the critical point? Critical point present here, that is -1 plus J0. Now apply the what? Principle of argument. What is the principle of argument? N is equal to P minus Z, where N is what? Number of encirclements. And one more thing, if direction is clockwise, we take negative sign for encirclement, means number of encirclement. If it is anti-clockwise only, we take what? Positive sign here. P is what? Indicate number of open loop poles located in right half of S plane. Even Z is also indicate what? Number of open loop zeros located in again right hand side of S plane. Now when we apply that, any number of encirclements for the critical point? No, it is outside. So number of encirclements is how much here? 0 only. Any pole is located in right hand side, look at here. for the given trans function where the poles are located, one is located -2, another one is located -4. There is no pole located in right hand side, so number of poles located is in right hand side of S plane is also 0 minus z. So now z becomes what? 0, and we even obtain n is equal to p. So from this condition we can say that system is what? Absolutely stable. Here we'll see another example on Nyquist stability criteria. As we discussed earlier, every time we are finding the what closed loop system stability by using what open loop trans function only. Okay, it is another frequency domain stability technique, right? Here when you look into this open loop trans function, what is the open loop trans function here? 100 by s plus 2 into s plus 4 into s plus 8. Okay, so when you just look at here, it consists of only 3 open loop poles, right? But all the 3 poles are located in what left half only. When you just draw the what pole 0 plot, right? When you draw the pole 0 plot, okay, where the poles are located, right? So -2, -4, -8. These are what open loop poles, right? So based on that, open loop system stability is not our interest here. We are finding closed loop system stability by using this technique. Okay, so we are using again concept of encirclement, but we need to map all these S-plane towards G of S-plane origin. What is G of S-plane origin? G of S-plane origin is what? -1 plus J0. This is our critical point. So when you are mapping here, okay, we are going with construction of Nyquist path. Okay, so construction of Nyquist path consists of several paths here. Okay, like S1, when you take S1 is to draw the what polar plot. Draw the polar plot. But here in this example it is a type 0 because there is no pole located at origin. Type 0, but what is the order of this trans function here? Order is what? 3, because 3 poles are there in time constant format. So it is a type 0 and order 3. So we can easily draw the what S1 path, okay, by using that simple shortcut by observing the what starting point and what ending point. Okay, so here I am mapping the what all the S-plane points towards what G of S-plane towards this critical point what -1 plus J0. So based on the encirclement concept, for this critical point only we are applying that principle of argument and identifying the what system stability. So that is the reason why we are mapping the what all the S-plane points towards what G of S-plane origin, that is the critical point -1 plus J0. Okay, so how to construct that S1 path? As I said, so it is just only to draw the what polar plot. It is easy for us only by observing the what type 0 as well as order 3. Means type 0 means where it starts. Type 0 means this is the starting point. As I said, type 0 starting point, type 1 starting point, type 2 starting point, type 3 starting point, and order indicates the what ending point of polar plot. If it is order 1, it terminates here. Order 2 means plot terminates here. Order 3, order 4. Now it is type 0 and order 3. So starting point is from here and order 3 means it terminates here. This is the what only like S1 path. Means we drawn that polar plot for the given trans function. Suppose if trans function is in different form, if it is not a standard one, because of the standard type only we directly draw this by using that simple logic. But if it is not in standard mode, we should again substitute s is equal to j omega and identify the what absolute values of both magnitude as well as phase angle with the variation of what frequency from 0 to infinity. Then only you can get the what polar plot. So it is easy for us because it is in standard mode. Next path is what? To cover entire right half of S plane. How to cover the entire right half of S plane? As I said, even in earlier example also, we need to go with a semicircle in right half of S plane. Semicircle with radius of how much? Suppose semicircle if I am indicating with r e power z theta. Okay, where r tends to what? Infinity. As I said, infinity amount of distance we need to cover. So right hand side means I am coming from this is what like a plus 90 and this is what minus 90. If you start 0 from here, this is what plus or minus 180 phase angle notation. So when I am covering entire right half of S plane, I need to start phase angle from what plus 90 to minus 90. Means wherever S is there, I should substitute r e power z theta, and r tends to what? Infinity, and theta is from what? Plus 90 to minus 90. So here when I substitute S is equal to r e power z theta, what is happening here? S is equal to r e power z theta, but r tends to infinity. For infinity you are adding 2, 4, 8 absolutely. There is no effect of 2, 4, 8. So what we get here in denominator approximated 100 by s cube we get. S cube means like r e power z theta whole cube, but r tends to infinity means something by infinity means we get 0 for the what? S2 part. For S2 we get what? Mapping only at this what? Origin. This is what? S2 part. Okay. Next, what is that S3 in sequence? S3 is to what? Just draw the what? Mirror image of S1 or inverse polar plot you can call. Inverse polar plot or mirror image of S1. Mirror image of S1. Just need to draw the mirror image of S1 like this only we get. So this is what S3. Okay, this is the procedure. Okay, in covering the what? Entire right half of S plane, we are following with this construction of S1, S2, S3. Okay. S4 also exists, but based on the given transfunction, S4 doesn't exist for this example. When S4 exists, when there exists a what? Pole or 0 at origin, only S4 path exists, but here there is no pole or 0 located at origin, so there is no S4 when you map into that what? G of S plane. That is the reason why we are not considering S4 path. Once again I am repeating, S4 exists only when pole or 0 located what? Origin only. Okay, so this completes our what? Mapping all the S plane points, okay, into that what? G of S plane towards this critical point. But what is the difficulty in this? Why we are facing difficulty in estimating stability for this example? We don't know that whether this minus 1 plus z0 present inside this circle or outside. Okay, when we can find that? When we are able to find the value of system gain at this position, okay, at this frequency, then you can find, okay, whether critical point is inside or what? Outside of that contour. Okay, for that we follow with this procedure. Okay, put S is equal to j omega, then g of j omega is equal to 100 by, okay, j omega plus 2 means wherever S is there we need to put j omega plus 4 into j omega plus 8. When you expand this denominator, okay, even if you separate the what? real and imaginary part. Okay, directly I am writing the result. When you separate real imaginary part, we get 64 minus 14 omega square. This is the what real part. Imaginary part j into, we get what 5 omega minus omega cube. That is not 5, it is 56 omega minus omega cube we get. Okay, so after simplifying the denominator, this is the result. But if you just look into our Nyquist path, what is that? At this position, where it is located, when you follow with the notation of the S-plane, it is what? Positive real axis. It is negative real axis. Positive imaginary axis. Negative imaginary axis. So it is on negative real axis. Real axis means imaginary part must be 0. Okay, to find this location only, I am equating the what? Imaginary part to 0. When I equate it to 0, what will be the result? We get 56 omega minus omega cube is equal to 0. If you simplify, 1 omega will get cancelled. That is 56 omega is equal to omega cube. We get omega square is equal to 56. Omega is equal to root 56 radians per second. Okay. This is what crossover frequency. Okay, exactly at this frequency, omega is equal to root 56 radians per second. Imaginary part is what? 0. So how to find this? At what point it is intersecting this negative axis? How to find this distance from the origin? When I substitute this frequency in this gain, okay, then I will get that point. Okay, so further if you substitute, what we get? G of j omega is what? Root 56 if I substitute. Okay, what will be the result? Anyway, root 56 if I substitute, this portion becomes 0. Then 100 by, we get what? 64 minus 14 into root 56 whole square. So simplify further, 100 by 64 minus 14 into 56 means anyway negative value because it is on negative axis. Result will be minus 0.14 we get if you simplify this. Means it is intersecting exactly at what? Minus 0.14. Got the point? We got the intersecting point with the negative axis by following with this procedure. Means where that minus 1 plus j0, that critical point present inside or what? Outside of this intersecting point or this contour? Definitely if it is minus 0.14, minus 1 plus j0 is what? Left hand side of that. So definitely critical point is not encircled by the what? Contour. Now when you apply the what? Principle of argument. Now we are applying the what? Principle of argument. What is that principle of argument? N is equal to P minus Z. So what are the number of encirclements here? No encirclement. Minus 1 plus j0 is outside, so number of encirclements is equal to 0. Is there any pole located in right hand side? We already indicated all the 3 poles are what? Located in left hand side, so there is no pole located in what? Right hand side. So minus z. So what we notice, z is equal to 0, n is equal to p. So now system is what? Absolutely stable. Okay. We'll see some other kind of examples under this Nyquist stability criteria. Here the trans function is 25 by s square into s plus 1 into s plus 5. When you just draw the pole 0 plot, where the poles and zeros located, no zeros are present in this trans function. 2 poles located at what? Origin. Okay. And 1 pole is at what? Minus 1. Another pole is at what? Minus 5. This is the what? Given open loop trans function. This I am drawing for what? Open loop trans function. Open loop poles we got. Now our interest is to estimate closed loop system stability. Okay. So for that only we are following with this stability criteria. Now in sequence we draw that Nyquist path. First one, S1 is to draw the what? Polar plot. Okay, so when you just look into this trans function, it is also standard trans function only. What kind of standard? It is a type 2. Okay, type 2. And what is the order? Order is how much here? 2, 3, 4. Okay, because 4 poles are there, order becomes what? 4. So follow the same procedure to draw the what? S1, or that is our polar plot. So when we draw the polar plot or the what S1 path, okay, by using this type 2 order 4 simple technique, what is that? Okay, so type 0 means starts along with this axis, type 1 means start along with this, type 2 means here, type 3 means this one. So now it is a type 2 system, so we start along with this axis 0, 1, 2. I am starting here, but what is the order here? Order 4 means order 1 means terminates here, order 2 means terminates here, order 3 means terminate here, order 4 means here. So when I start from type 2 to order 4 means this kind of path we get for the what S1. This is what S1 path. What is S2? S2 is to cover the entire right half of S plane. How to do this? Wherever S is there, substitute R e power z theta, because right hand side of S plane means it is just a what, a semicircle with the radius of R e power z theta, but R tends to infinity and theta is from what plus 90 to minus 90. How it is? Plus 90 to minus 90, this is what 0. Phase angle we count in anti-clockwise direction, this is plus 90, this is what 180, this is what minus 90, or this is minus 180, like this. So limit R tends to infinity and theta is from what? Plus 90 to minus 90, we should substitute. Look at here, wherever R is there, R tends to infinity, theta is from 90 to minus 90. So look into this trans function 25 by, anyway absolutely there is no difference, s power 4 we get, so s power 4, so 25 by s power 4 means R e power z theta whole power 4, but R tends to infinity, theta is from plus 90 to minus 90. Substitute here, we get infinity, sorry, not infinity. So what will be the result? We get 25 by infinity means something by infinity means answer will be 0, means when you map the what entire right half of S plane into that J of S plane origin, so we get S2 at what origin only. Okay, what is S3 here? S3 means it is just a mirror image of S1. So we just need to draw like this. This is what S3. This is a procedure, okay, to construct the what Nyquist path, means we are mapping entire S plane towards what G of S plane towards this critical point minus 1 plus Z0. But here up to now, when you look into the previous examples, there is no pole or 0 located what origin, right? In previous examples there is no pole or 0 located what origin. That is the reason why S4 is not exist in that. But here when you just look into this, 2 poles are located what origin. So here we need to construct that S4 path. What is S4 path? S4 path exists when a pole or 0 present at origin. So what we need to do for S4 here, Okay, this is what S-plane mapping. Okay, this is what S1. So we are starting from omega 0 to omega infinity. So that is nothing but polar plot only. This is S1. This is what S2 we are constructing to cover the what entire right half S-plane, and this is what S3. Simply it is just mirror image or what inverse polar plot only. But what about S4? S4 only present because of the what polar 0 at what origin. So after reaching here, because of that poles present at origin only, so we are just mapping from here to here by adding this what additional path. What is this? This is what S4. So after reaching here, phase angle is how much? Minus 90. Here how much? Here plus 90. But origin means what will be the amount of radius present? Radius is 0 only. So wherever S is there, substitute r e power z theta. But here limit r tends to 0. Theta is from what? Look at here, theta is from minus 90 to plus 90. This thing we need to do here. For that only substitute here 25 by, look at here, for that S4 path only we are doing this activity. So wherever S is there, substitute r e power z theta, but r tends to 0. No need to do in this because 0 plus 1, 1 only, 0 plus 5, 5 only. So there won't be any effect of these poles. Only effect of poles present at origin only. So 25 by S square means what we get? R e power z theta whole square. Okay. So 25 by r square e power z 2 theta. But limit r tends to 0. Theta is from what? How much we have? Minus 90 to plus 90. If you substitute, what will be the amount of 25 by something by 0 means we get infinity. E power z to theta, if you write into numerator, we get what? Minus sign. Minus of minus becomes what? Plus 2 will get cancelled. So we get what? Infinity e power j phi to infinity e power minus j phi. This is the magnitude for the what? S4 path. Okay, so when we map this infinity e power j 180 degrees phi means to the what? Infinity e power minus j 180. If you just look into this, this is 0 plus 90, okay, plus 180, but this is minus 90, this is minus 180 because upper one is what? Anti-clockwise direction, lower one is in clockwise direction. This is the notation. But after reaching S3 path, how the starting point of S4 present? Infinity e power plus j phi. So we are moving towards positive 180 side. But infinity amount of radius is present. Infinity means I need to draw like this. Okay. Again infinity. But ending point is what? Towards minus. So we'll reach like this. Got the point? Infinity means we are covering entire plane, but starting point is towards plus 180, so we are going in upper part. So what will be the direction we get? This is the word direction we get. Okay, this is the path for what? S4. So ending point, because wherever starting point is there, we are mapping towards this. So this is completion of the what? Nyquist path by mapping all the S-plane points towards what? This is G of S-plane. What is a G of S-plane origin? That is a critical point. We mapped all the points towards this plane. Now you can apply the what? Principle of argument. What is the principle of argument? Okay, n is equal to p minus z. What are the number of encirclement? Yes, minus 1 plus j0 is having what? 2 encirclements. What is the direction? Look at here. Inside we have 1 encirclement. Okay, outside is also another encirclement, but both are in which direction? What is the direction here? This is clockwise direction. Got the point? Clockwise direction we got. Clockwise direction means what is the value? Negative sign we need to place for clockwise direction. Positive sign we place for what? Anti-clockwise. So minus 2 we are taking because 2 encirclements in what? Clockwise direction. So minus 2. Is there any pole located in right hand side? Look at that pole 0 plot. Only 2 poles at origin and 2 poles are in what? Left half S plane. So there is no pole located in what? Right hand side based on the given trans function. So minus Z. Here Z is equal to 2 means Z is not equal to 0 where N is also not equal to P. So condition is not satisfied. How to say that particular system is stable? Number of encirclements must be equal to number of poles located in right half S plane and number of open loop zeros must be 0 in right half S plane. But we didn't have that condition, because of that system is what? Unstable. So this comes in what? Unstable category.